This is lesson 41 for 7th grade, and today we're talking about using some formulas and using the distributive property. This will probably be a bit of a review, and it's going to lead into the distributive property, which we may or may not have seen before. Typically in 7th grade it's a fairly new concept, even though we're going to show that they probably know that they can use it. So here's what we're going to focus on today. We want to be able to manipulate formulas to solve for certain variables, and we want to apply the distributive property when necessary and understand why we can do this. Okay, I will be moving as quickly as I can because my projector has been acting up again. Hopefully it won't be any issue for us right now. Okay. So in lesson 20, it was stated that the area of a rectangle is related to the length and width of the rectangle by this formula. So area equals length times width. Okay, and this is what it means. The area of the rectangle equals the product of its length and width, or just like I just said, length times width. If we're given a length and width, or if we're given a length and a width, we can replace the letters in the formula with the numbers and calculate the area, kind of like this. So we can find area using this formula when we know what L is and when we know what W is. Basically, if we had a rectangle that was 8 feet by 4 feet, we could just plug these two things into the formula. They tell us what L is, so I'm going to drop these things down, and I'm going to replace L with 8 because L is 8 feet. I'm going to replace W with 4 feet because W is 4 feet. And you'll notice that I put equal signs because is in math means equals. So now we do 8 times 4, and we get 32. And we've got 2 feet that we're multiplying together, just to remind us that we should be in feet squared because we are dealing with area. Okay? So 32 feet squared for that one. Or 32 square feet. So let's take a look at this one. Erase that. Okay. Evaluate. And that's usually what they tell us when we're going to be replacing letters with numbers. To evaluate 2 times L plus W when L is 8 centimeters and W is 4 centimeters. So 8 centimeters and 4 centimeters. I'm going to replace L with 8 centimeters. We're going to add 4 centimeters. Okay, we're not multiplying anymore like we were up here, so our units will stay the same. We actually have 2 times 8 plus 4, so 2 times 12 centimeters. Sorry, a little sloppy there. And we'll get 24 centimeters. Okay. And the reason that we are in centimeters there, not centimeters squared, is because we were adding here, we were not multiplying. When you multiply, that's when we're talking about square units. When we add, we're talking about just the regular units. So that's why we're at 24 there. Okay. So that's evaluation, or kind of manipulating our formulas there, plugging in what is known. We call that substitution or evaluation. Oh, looks like I have this one on there twice. We just talked about this one, and we went through it, and we got, what, 24? Yeah, 2 times 12, okay? Okay, we'll do this in class. But basically what we're going to be finding out here is that you can take your perimeter, this is a perimeter formula actually, length plus width and then double it, okay? So normally when we are finding perimeter we could add up all the sides. Length plus width plus length plus width. But we have the widths that are the same and the lengths that are the same. So a lot of times we see the formula this way. She finds the perimeter by adding the length and width and then doubling that number. That's kind of like what we did here. But Kurt's method, he finds the perimeter of a rectangle by doubling the length and doubling the width and then adding those two numbers together. So he doubles this and doubles this, and then adds those together. We should find out that we get the same answer. Okay? So these are two commonly used formulas for the perimeter of a rectangle, and it's in the terms of its length and width. Okay? So 2 times the sum of length and width, or 2 times the length plus 2 times the width. Okay? This is all helping us lead into the distributive property, but let's just show that both of these are going to work. It says use the 2 perimeter formulas to find the perimeter of this rectangle. 30 inches by 20 inches. Okay, if we added up all the sides, let's just do that quick. 30 plus 20 is 50, plus 30 is 80, plus 20 is 100. So we should be getting 100 inches here. Well, first let's try this formula. P equals 2 times L plus W. Okay. I'm not going to use the units in this one just to save on room. Alright, so our length is 30 inches and our width is 20. So we're just taking what we have for length, putting that number in, what we have for width, putting that number in. Then we add these together. We do what's in the parentheses first, and we get 30 plus 20 is 50. And we all know that 2 times 50 equals 100 centimeters. So we should get 100 centimeters there, and that's what we got when we added all the sides up. So good, this one works. Let's try this one. Perimeter equals 2L, right like that, so that it doesn't look like a 21. So 2 times the length, 2 times 30, plus 2 times the width, 2 times 20. Okay, 2 times 30 is 60, 2 times 20 is 40, 60 plus 40 is 100. So we still get 100 centimeters. Alright, so both formulas work. Now we're going to observe a little bit about that. We're going to kind of look at why those things both work. Okay, so perimeter formula is usually what we use to introduce the distributive property. Basically, these are our 2 different ways to get perimeter. And what happens here is usually we would add these 2 together first, then multiply by 2. But what we can do is distribute that 2. 2 is being multiplied by the length and the width. So that's what these arrows are for. Times by the L, times by the W. So this actually is 2 times L plus 2 times W. They equal each other. And we're just multiplying each term inside here by 2. Okay? So we can show it with variables. This is what we mean. A times B plus C equals A times B plus A times C. And it also works for subtraction. Okay? So you're taking whatever number you have out here, multiplying it by both the terms inside. There could be a lot more than 2 terms inside the parentheses. For now we're just going to deal with 2 things. But yeah. That's basically our distributive property. And we're going to show how this works in 2 ways with this example right here. So normally what I would have my students do, or you, is add what's in the parentheses first if you can. We're going to have situations where we won't be able to do that, and I'll point that out. But let's go with method A. We're going to add first. So 6 times 20 plus 5. Let's add these first and we'll get 25. So 6 times 25. 6 times 25 we should get 150. Okay? You can check that on a calculator or do it by hand if you want. Method B, we'll use our distributive property, and I'll use method B over here. Okay, 6 is being multiplied by each thing on the inside. So this is 6 times 20 plus 6 times 5. Yeah? 6 times 20 is 120 plus 6 times 5 is 30, and 120 plus 30 is 150. So that is our distributive property, and it should show us that we can do that and still get the same answer. And in fact, in this type of problem, it might have been easier to use the distributive property because I knew this one in my head, but I had to think a little bit more. This was, okay, 6 times 20, 120, plus 30, 150. Much quicker. So we have these options available to us. Moving on to our last example, it looks like. Sorry about that. Let's get back to that. Sorry, there we go. Alright, this would be a situation where we cannot add what's on the inside because we don't know what this is, okay? We're going to have to simplify as much as we can, but we can only do it so much, okay? So we have to remember here, if this was a number, we could add these together then multiply, but it's not. So we have to use our distributive property. This means 2 times 3 plus 2 times n. And it's okay that we don't know what n is, and then we have a plus 4 at the end. Okay? Well, let's see what we can do here. We know 2 times 3 is 6. Drop everything else down. Plus 4. We can combine 6 and 4, so 6 plus 4 is 10. And then we still have a 2 times n left. That is the simplified version of that statement. Okay, so that's where we would have to use the distributive property. Fairly new concept, so we'll be spending some time on it, but that's all I have for today.